Good morning. I want to talk about summarizing quantitative data with blocks, plots, and outliers. So yesterday we talked about interquartile range and other measures of variability, but today we're going to talk about how we can use the interquartile range as a ruler to identify outliers. Now, how can we do that? Well, we can use the 1.5 times the IQR rule. What this means is that if it falls more than 1.5 IQR times the IQR above the third quartile, or 1.5 times the IQR below the first quartile, we can now call that number an outlier. Okay, and that's what we have here. Low outliers is less than Q1 minus 1.5 times the IQR, and high outliers are greater than Q3 plus 1.5 times the IQR. Now, what does this mean in terms of numbers? Let's look at example number 12, home run king. Here are the data on the number of home runs that Bonds hit in each of his 21 complete seasons. We're going to identify any outliers in the distribution, if there are any, and show your work. Now, you know I'm a stickler for putting a whole bunch of numbers here because we like to make things hard, and they're not in order. So what I actually did was I went through and I ordered them in ascending order. By looking at this, you might think that 73 or 16 could be outliers, but now we can actually test for it. Okay, so the first thing we need to do is we need to find the median. There are 21 numbers, so that means the median's gonna be somewhere in here. We're not gonna have to find an average. So if we have 21 numbers, that must mean that the 11th number has to be the median. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this number right here, 34, is our median. Okay. Now that we find our median, we can find our quartiles. So we're going to look to the left side of our median first. So we have these 10 numbers. So in order to find the quartile, the first quartile, we need to find the middle of these first 10 numbers. So that's going to be the number between 5 and 6. So 1, 2, 3, 4, 5. And then we have 5 on the other side. But this number right here is going to be our first quartile. What's in between 25 and 26? Well, that would be 25.5. Okay, so quartile 1 is 25.5. Now we need to go to the other side. We know we're going to be looking between the 5th and 6th number again. 1, 2, 3, 4, 5. So we're going to be looking in between here. And that one's easy. That one's just going to be 45. So now we have our quartiles and our median. So now all we have to do is find the IQR. Remember that the IQR is equal to quartile 3 minus quartile 1. In this case, we have 45 minus 25.5. So our IQR is equal to 19.5. What do we do with this number? Well, we're going to use the formula we have up here. So to find our low outlier, what we're going to do is we're going to take Q1, and we're going to subtract 1.5 times our IQR. Our quartile 1 we found was 25.5 minus 1.5 times our IQR, which was 19.5. We can stick all of that into a calculator, and we'll actually get negative 3.75. Interesting. Okay. As we can see, none of these numbers are less than negative 3.75, with our lowest being 16. So let's look at our upper end here. So our upper outlier, or high outlier, would be Q3 plus 1.5 times our IQR. Q3 was 45 plus 1.5 times our IQR of 19.5. Okay, and if you put this all into a calculator, you should be getting 74.75. Okay, there are no numbers over here that are greater than 74.75. So even though 73 looks like it could possibly be an outlier, and maybe you would have made that mistake yesterday, it is not. So we can say that there are no outliers. Not too hard. Okay, so it is important to identify outliers in a distribution for several reasons. One, they might be inaccurate data values. Maybe somebody made a mistake. Maybe instead of measuring in centimeters, they measured in inches or vice versa. They can indicate a remarkable occurrence. Maybe someone's just superhuman and can lift a whole bunch of weight compared to everyone else. You never know. And three, they can heavily influence the values in some summary statistics. As we can recall, the standard deviation and mean are not resistant to outliers. So by identifying them, we can talk about that later when we go into our conclusions. The next thing I want to talk about is our 5-number summary of a distribution. Now, the 5-number summary of a distribution of a quantitative data consists of the minimum, the first quartile, Q1, we just found that up here, the median, and the third quartile, Q3, and the maximum. Okay. How can we arrange this data so that it is easy to see? Well, we can arrange it all in a box plot, which is literally a visual representation of a 5-number summary. So let's look at an example. How big are the large fries? Ryan and Brent are curious about the amount of French fries they would get in a large order from their favorite fast food restaurant, Burger King. They went to several different Burger King's locations over the series of days and ordered a total of 14 large fries. The weight of each order in grams is shown here. Of course, they're not in ascending order, because why would I be easy like that? Okay, so the first thing we need to do is we need to put them in ascending order so we can find the 5-number summary. So in ascending order, they are 152, 159, 160, 163, 165, 166, 166, 167, 168, 168, 170, 170, 171, 171, and, I almost ran out of room here, 173. Okay, so let's go through and look at our 5-number summary. Well, first we have our minimum, okay? Then we have our maximum at 173. Now we have 14 locations here, so that means our median is going to be between the 7th and 8th number. So if we look here, 1, 2, 3, 4, 5, 6, 7, 8. Our median, let me count that again. Yep, 1, 2, 3, 4, 5, 6, 7. Our median is going to be right here, okay, at 166.5. Okay, which means this is our lower half and this is our upper half, and each one of them include 7 fries. So now we're looking for the 4th number in order to find the quartiles. 1, 2, 3, 4. This is our Q1, and then 1, 2, 3, 4. This is our Q3. So now we have a 5-number summary. But before we actually do that, we need to make sure that none of these are outliers, because it's definitely possible now that we know that there could be outliers, or there not could be outliers even though they look pretty obvious. Maybe we look in here and we don't see an outlier, but there is one. So before we do that, I want to find the IQR. The IQR is equal to 170 minus 163, quartile, just in case you guys can see it, which is equal to 7. So we would do 163, which is our quartile 1, minus 1.5 times 7 to get 152.5. And we do 170 plus 1.5 times 7 to get 180.5. Now if you look here, we do have a sneaky outlier here at our minimum. So 152 is actually an outlier, and we're going to talk about how to graph that in just a moment, which means 159 is going to be not our new minimum, but we're definitely going to show 159 on our box plot. Okay, so let's actually make that box plot. First thing we should do is we should draw a number line, hopefully a straight number line. I can't draw a straight line to save my life. We all know that. And what we're going to do is we're going to go from 150 by 5s all the way up to 175. So we have 160, 165, and hopefully you guys do a much better job at doing this. I know you can. 175. Okay? Now, what we would do here is we would first graph our outlier, which is at 152. Now this could be a dot or a star. I know you guys like stars, so let's make a little star there just to show that we have something at 152. Then we're going to go to 159, which is where our start begins outside of our outliers. Okay, so our minimum is here. The next thing we would go to is our quartile 1. Our quartile 1 is at 163, which is going to be a longer line, and you'll see why in just a moment. Then our median is at 166.5, which we'll say is right about here. And then our maximum, our quartile 3 is at 170. So as you guys can see, this creates a little box. Okay, our maximum is at 173, which is right about here. Now we connect this line and this line right here to the box. Those become our whiskers, which is another name for this plot, a box and whisker plots. So here is our box plot with our outlier, and as you guys can see, this is pretty symmetric, okay? Not including the outlier. It's obviously skewed left with the outlier. So according to the nutrition website, Burger King's large fries weigh 160 grams on average. Ryan and Brent suspect their local Burger King restaurants may be skimping on fries. Does this graph in part A support their suspicion? So let's look at where 160 is for a moment. 160 is right here, okay? What do we have above 160? Well, we have this first quartile at 163. So that means that less than 25%, because remember our first quartile is 25%, okay, have 160 grams. So this may not mean that they're actually skimping. This means that they might be actually over-serving. So let's write that out in a sentence. Because quartile 1, not quartile 3, is at 163 grams, okay, only 25% are less than this. This means that, what are their names? Ryan and Brent got served more than 160 grams of fries. 75+% of the time. Lucky them. So, and you can pause it if you need a little bit more time. But we're going to go on to this last example here. Okay, let me just make sure it's all on the window. You got to be careful because box plots don't show gaps, clusters, and peaks, which could alternate or change your view of the data. So you just got to be really careful of that. Let's move on to the last example, which is example number 14. Which company makes a better tablet? Ironically, I am recording this on the iPad. So in recent year, Consumer Reports rated many tablet computers for overall performance and quality. Based on several variables, they gave each tablet an overall rating, which higher scores indicate better ratings. Overall ratings of tablets produced by Apple and Samsung are given below. So we have all of these data points here and all of these data points here. And then we have individual data from what we have here. So we know that the means are here, standard deviation, and then we have the 5-number summary. And look at this, we don't even have to do math to find the IQR. They're right here. Then if you look down here, we don't even have to do math or use the IQR to find our outliers because they're already mapped on the graph for us, okay? We can see that those outliers are in Apple and they are at, let's see, what are our lowest two here? We have 73 and 76. So 73 and 76 are our outliers, okay? Now, what we're going to do is we're going to compare the overall rating distributions for Samsung and Apple. How are we going to do that? Well, we're going to remember our SOCs. So S. The first S stands for spread. Okay? Now, we have both the standard deviation and the IQR, and we can find the range, so we can actually describe it however you want. So let's describe it two different ways here, because it's very clear that both the standard deviation and the IQR for Apple is smaller than Samsung. So that's what we can write here. Both the standard deviation which is 3.762, and the IQR, which is 3, for the Apple tablets, is less than the Samsung tablets. Which are 6.74 and 11 respectively. O stands for outliers. And you guys can list them just like this. There's no problem with that. We already talked about how Apple has 2 outliers. So Apple has 2 outlier scores at 73 and 76, while Samsung has no outlier scores. Okay, centers. So if we look back up here, we have our center, our mean for Apple is 83.45, and our mean for Samsung is 79.83. We also have another measure of center, the median, where Apple is 84 and 83. And Apple is both better in both of these centers, so we can say that. So we can say something just like the spread. So both the mean, which was 83.45, and median, which was 84, was better for the Apple tablets than the Samsung tablets. And those again were 79.87 and 83 respectively. The last thing we need to talk about is the shape, which is our last S. Now if we look at these, they both appear to be pretty skewed to the left. So let's just say that. Remember, the outliers are included in the shape. This one is a little bit less skewed to the left as this one is, but they're both skewed left. So both of the distributions, for the Apple and Samsung tablets are skewed left. Right? Because you can see right here, this is a long tail. This is a very long tail compared to this very short tail. Okay, so there's more data over here, and there's more data over here than this little guy right there. So both of them have a tail that's definitely longer on the left. Therefore, they're both skewed left. Hope you guys understand this. Please email me with any questions, or you can wait until Thursday.